Okay, so we want to make sure that we get our homework from classifying triangles, which was lesson 4.1, done for tonight. It should not take you, really much longer than like 10-15 minutes. Because, how long does it take to go, hey, this is an isosceles. Oh, that is a scalene triangle. Okay, since this is an equilateral triangle and you give us this information, we can find x so that the measures are equal. That's literally how complicated that homework is. Okay? What we're going to start looking at today is angles of triangles. Okay? That homework is going to be due for tomorrow. And then I'm going to give you guys a chance to maybe get caught up, see if there's any, missing assignments that you could possibly turn in for me that haven't already been turned in. So I want to make sure that you guys have a good grade for the semester. And also gives you a chance for maybe any work that we need to do to improve your test grades.
So I turned in my missing?
Yeah, I doesn't mean that I did anything over the weekend. Okay, so if you've turned things in, I still have to go through today and put in the pendings for those and look at grading. The grading of late things always gets shunted behind the stuff that is current. So if you have it in, it will be graded, it just has not been entered in yet. Okay, so let's look at these triangles once again, and obviously we always start out with a review. This slide never likes going on. So what kind of triangle is RST? Here's our choices.
Obtuse?
You say it's an obtuse. Now, how are you classifying this triangle if you say obtuse?
By the 102.
Wait.
Okay, by the 102, which is an angle. So classifying by angles,
Yeah.
we say that this is
It has
obtuse.
to be obtuse.
I would agree. If I were to classify by sides, what would it be known as?
Equal.
No, it would be like the second one.
Which
Let me
is,
check.
starts with the letter I.
Isosceles, yes.
Isosceles. Okay,
I
where two
thought
sides
it
are
was
the same.
isosceles, but I didn't know.
Okay. Find y if RST is an isosceles triangle with RS congruent to RT. So here we have to determine what y is. Okay. So how would I do that?
So that's an equation.
Set up an equation. So what is my equation going to be?
5y
5y plus
6
6
equals 3,
3.
2y minus 2.
No, parentheses.
Okay. What would I do next?
We would distribute.
Okay. I
Three.
like that distribution. 3 times 2y. 3 times negative 2. Now bring the y's all to the same side. I could do it this way. I could go subtract 6y, subtract 6y, and I'd be left with negative y. If I break, so this is doing that, subtract 6y, subtract 6y. If I subtract 6 from this side, I could subtract 6 from this side. So 6 subtract 6 is 0. Negative 6, subtract 6, negative 12, y equals 12. Okay, be careful with your algebra. Quite often you guys get this step, and then when it comes to the rest, we fall short. And so every time that you show me the work, I can give you credit for the work, even if you get the wrong answer at the end. If all you do is you leave me an answer and you said y equals 7, I'm like, where'd that come from? Okay, let's find x if ABC is an equilateral triangle. So what do we need to do this time? Pretty much the same as before, right? Do I need to worry about all three sides?
Mm-mm.
No, because all three sides are the exact same length. All we have to do is set two of them equal to each other so we can solve for x. So let's go with the 6x plus 5 is equal to 4x plus 13. Okay, bring the x's together, subtract 4x, subtract 4x, I'm left with 2x. If I subtract 5 and subtract 5, I'm left with 0, and this one becomes 8. So x is equal to 4, because I divide both sides by 2. Now, did this throw you off at all, the fact that there was this perpendicular that divided things?
Well, I
Did you
mean,
worry a little bit when you saw that? That you might have to figure out a midpoint and...
no, because
No?
there has to be a perpendicular there.
No, there doesn't have to be a perpendicular there. They could have left that out. They didn't have to include point D. We're ignoring it in this case because it didn't apply to triangle ABC. It wasn't something we had to worry about at this time. But you notice that they use that same image, but they ask a different question. And this is quite often what I'm doing on our quizzes and tests, is we take the same image from the review, but we ask a different question that's also related. It says, name a right triangle if AD is perpendicular to CB.
Well, I mean,
So what's a right triangle here?
A-
You got two choices, right?
ADC.
Yes.
ADC? That would be correct. What would be the other possible, one from the picture, not necessarily listed here?
ADB.
ADB.
Yeah.
Okay? Both the left and the right are right triangles. So this is as difficult as your homework really is. Okay, classify M and O as scaling, isosceles, or equilateral. And they give us the links. MN is 12, NO is 9, MO is 15. How many sides are the same length?
None.
None.
So this is a scaling.
This is a scaling. How many sides need to be the same size for isosceles?
2,
How many for equilateral?
All
3, all.
All 3. So this is scaling. All sides, different lengths. Which of these is not a classification for FGH? So three of them do classify this correctly, though there's one that doesn't.
Scaling? Or wait, isosceles.
It's either B or C.
Okay, so there's a question here. Is it this? Is it this? We know it's acute because all the angles are less than 90. We know it's equiangular because they're all the same measure. So which of these is a better description that would fit this, and which one would never fit it?
Wait,
Scaling, I feel like.
yeah, scaling would basically never fit because,
Scaling would never fit because we would need 3 different side lengths.
and like you could say that.
You could say this is isosceles,
Yeah,
but
you
it's not
could.
the best description.
It's not the best, but
But do we have at least 2 sides the same length?
Yes.
Yes.
yes, possibly.
This is not the best description, but you could use it. So scaling is the thing that is not the classification. Okay, so let's take a look at applying a new theorem called the triangle angle sum theorem. I think you guys will like this one. It makes your life a little easier. Do you know what it basically says? If I have a triangle and I sum up all the angles of the triangle, I'm going to get
180.
180. And we're going to apply the exterior angle theorem. Okay, so we have some new vocabulary. We're going to click through so we get the whole thing on there. Okay, we're going to be talking about exterior angles once again. We're familiar with those. Remote interior angles. I'm not really sure what remote means yet. we have a new type of proof called a flow proof. A corollary is similar to our postulates and theorems. Why do they call them a different name? There's reasons. Corollaries are kind of like sub-reasons, okay? And we're not really sure what an auxiliary line is, other than we expect some kind of line that may be doing some sort of helping.
So you mean like a corollary would be an example, like, so postulate would be like, Miss Leeson's iPad is green. The corollary would be Miss Leeson's iPad is lime.
Possibly.
Like that? Okay.
Yeah, something along those lines.
Because it's going like a sub deeper.
Yeah, let's take a look, okay? So here is this theorem that you can find in your reference guide, that cheat sheet that we really love everyone to use. Okay, triangle sum theorem. This is theorem 4.1. The sum of the measures of the angles of any triangle will equal 180. So no matter what triangle we have, all three of these angles will add up to 180. So if I know two of the angles, I can very easily find the third. If I know the measure of one, okay, I need some information on one of the others to help me also find that third.
Well, I mean, unless the first angle is 60.
It also depends on the type of triangle.
Never mind, you're right.
It does. I see where you were going on that, Nathan. He was thinking, well, if I have a 60,
Then all
he's
the other
expecting
sets
equiangular, but you can still have something where there's
like
a
50
60.
and 61.
In fact, this one here, I would hazard to guess is probably a 30, 60, 90 triangle. It's a very common triangle as well for geometry. Okay, and so they have this proof. What kind of proof is this one? Do you remember? What do they call this? Where we set it up, where we have this given and what we need to prove, and then they set up this and this.
I thought we just called these proofs.
Yeah. Like
Now, well, we talked about paragraph proofs. Do you remember those?
Oh, yeah.
Where we had to write it like a paragraph.
So I'm guessing these are...
The name kind of comes from this.
statements and reasons.
Yeah, which is column 1, column 2. This is a 2-column proof.
Oh, okay.
Does that name not seem familiar? That was happening a lot in your homework, unless it was avoided. Write a 2-column proof for. Write a 2-column proof for.
I thought paragraph proofs were just 2-column proofs.
No, paragraph proofs are where you're writing it sentence by sentence,
See,
like a paragraph.
I remember doing these. I just don't remember the name of them, but I remember how to do them.
Okay.
Yeah, I remember how to do them.
Well, I'm reminding you of the name. Okay, so let's take a look at this with the information that we are given so far. So here we have an example where we have two different triangles and we have two unknown measures of angles in the center. Oh, and actually a third one out here. It says the diagram shows the path of a softball in a drill developed by 4 players. Find the measure of each numbered angle. So where would you begin? Would you start with the triangle on the left or the triangle on the right? No guesses?
Left,
Why?
You could...
just because it has more measurements.
Yeah, I'd start with the one on the left because there's more information available to help me find angle number 1.
Oh, okay. I thought
Okay?
the one on the right had angles 79
the left-
and angle 3.
On the left,
Like, I thought that was
I
the
know that
degree.
I have an angle that measures 43, one that measures 74, we have an angle 1, and the three of them together have to equal what? What is the sum of all the measures of the angles in a triangle?
180.
180. So the measure of angle 1 has to equal 180 subtract 43 plus 74. Or we could say minus 43 minus 74. Okay. So this is 110, 117. Anyone able to check my math? 180 subtract 43 subtract 74, and we're left with 63. So now we know that this one measures 63. Does that help us?
Well, yeah, because it'll help us figure out what angle 2 is.
So how do I figure out angle 2?
Well, because
They're vertical?
They're vertical.
yeah, they're vertical.
Because it's a vertical angle, this is also 63. And because we know this is 63 and this is 79, can we figure out number 3?
Yes.
Yes. So the measure of angle 2 is equal to the measure of angle 1, which is 63. Okay, and then our third one, this is still looking at the right. Okay, we have 79 plus 63 plus the measure of angle 3 is equal to 180. So the measure of angle 3 is 180 subtract 79 subtract 63. (180) subtract 79 subtract 63, and I'm left with the measure of angle 3 equals 38. So now I have all 3 angles. Was that really hard to do? No, it really wasn't at all. Okay, so let's see if they did things in the same way. So we got 63, 63, and 38. They're going to run us through it and see if we notice any differences. So it says you know the measure of 2 angles of one and only 1 measure of the other, and that 1 and 2 are vertical angles. You find the measure of angle 1 because the 2 angles of that triangle are known, and then use vertical angles to find the measure for 2, and then now we'll have enough information to find measure of angle 3. So they use the triangle angle sum theorem and determine that the measure of angle 1 is 63. From that, we know that 1 and 2 are congruent, so measure of angle 2 is 63 because of the vertical angles. Use the triangle angle sum theorem again, and we find that the measure of angle 3 is 38. And that's exactly what we got. Okay, justify, when we add up all those angles, we should have each triangle summing to 180. Okay, so you notice they say by identifying each part of the problem, this complex problem is separated into manageable pieces. And then we use the properties of triangles to check the reasonableness of the answers. Okay, find the measure of angle 3. They're not concerned about 1 or 2. They just want to know what's 3.
Well, yeah, we have to find both of them.
We can solve it like we solved the other one.
We solve it exactly like we solved the other one. Okay, but in this case, they're not concerned about what we get for the first parts. All they're concerned with is the final answer here. So we still solve this the same way. The measure of angle 1 plus 38 plus 67 is equal to 180. Measure of angle 1 is 180, subtract these other two angles. 180 subtract 38 subtract 67, and I'm left with 75. Seems reasonable. Seems about the right size. If that's 75, that means that 2 is 75. And then we now know the measure of angle 3 plus 75 plus 48 equals 180. So the measure of angle 3 is 180, subtract those other two angles. And I'm left with what? 57. So same process as before. Now, what would happen if they changed things slightly and they actually gave you this part and they gave you this part and you had to figure out this one? Would that change anything?
No, because wouldn't they be like...
Because you'd still know this. Okay? So think through what information that they give you and where you need to get to. Exterior angle theorem. Okay, the measure of an exterior angle of a triangle what's an exterior angle? The exterior angle is this one right here. An angle that is outside of the triangle that is on the other side of it. It's the extension of one of these sides, okay, and we get this exterior angle. Now this angle is equal to the sum of the measure of the other two angles that are kind of opposite. These are these interior angles. So if I want to find out what is the measure of this angle 1, I add up the angle at A and the angle at B. That's literally how we do it. Okay, so we're going to put this into action. Okay, once again, they give us a proof, but this is a different type of proof. So if we had paragraph proofs where we wrote everything sentence by sentence in a paragraph, we had our 2-column proof. This one is known as a flow proof of this theorem. Okay, this is a flow chart. Now you'll notice we don't just have A going to B, where we have, simply, given going to what we are trying to prove. In this case, there is more than one path, or can be more than one path, to get to what I'm actually trying to get to at the end. That's why they do this as a flow proof. Do we still do this sometimes by just listing the other side, underneath, and we kind of flip to a different idea, sort of? Yes, we can, but this is another type of proof that we can do. Okay? So here, they show that the given is this particular triangle. We're trying to get to this point where the measure of angle A plus the measure of angle B equals the measure of angle 1. So they go from here to the triangle angle sum theorem, where they take these three angles and sum them together to equal 180. How 1 and 2 here on this side form a linear pair. So if they're a linear pair, they're supplementary, which means that these two equal 180 when added together. Then we use substitution to set these two equal to one another rather than 180. And then we subtract away this measure of angle 2. So I'm left with this measure of angle A plus measure of angle B equals the measure of angle 1. So this is how they went about proving this particular theorem. Okay, find the measure of FLW. We need to know what is this in this particular image. Where do you begin? Some people are like, this looks like a mess. What was the theorem that we just learned? What did that theorem tell us? That this exterior angle, which is given by 2x minus 48, is equal to what? These two angles here that were interior angles that were opposite it. Okay, not the supplementary one, but the other two. Is it as hard as it seemed when you first looked at it? No. We're gonna solve for x. Subtract x on this side, subtract x, I'm left with x. We're gonna add 48, We have 0 left on this side, but this side I have 80. X equals 80. Okay, so that solves for this. But we needed to find out what FLW is, not just X. We're not done. How do I find FLW rather than just X?
Put the X back into the...
Put the X back in. Okay, 2x minus 48. That means it's going to be 2 times 80, subtract 48, which is equal to 160, subtract 48. Subtract 48, you get 112 degrees is equal to the angle FLW. Was that a lot of steps? No. It's just making use of this additional theorem that we've just learned. That exterior angle equals the sum of those two interior angles. So they're going to show you how they do it. Exterior angle theorem. They plug in the information, they solve, and they find that x is equal to 80, just like us. So we plug that 80 into our equation for FLW, and we're left with that the measure is equal to 112. Okay, so we're going to do the same type of thing now to determine the measure of ACD. ACD is this one right here. So how do I solve it?
3x plus 10 equals x plus 90.
3x plus 10 is equal to x plus 90. What theorem are you using?
Right angle.
The exterior angle theorem. This is the exterior angle, and it's equal to these two interior angles, x and 90. Solve for x. Subtract x, subtract 10. I end up with 2x plus 0 is equal to 0 plus 80. X is equal to 40. Am I done?
No.
But it's an answer choice.
No.
What do I need to do?
Put the 40 back in.
Put the 40 back in. 3 times 40 plus 10 is equal to, which is our choice? What's the correct answer?
130.
130.
Oh.
What? I disagree. They pulled a student move. It can't this angle certainly does not measure 40. That would be an acute angle.
Yeah.
This is not correct. They didn't take that x. We solved for x. X is that. That's not what they asked for. We needed this here. Plug it in, we get 130. This is your answer. See? Textbooks, teachers, we make mistakes too. The important thing is to catch it and understand why you're doing the things that you're doing. Okay, corollaries. So these are kind of sub to the triangle angle sum theorem. Okay, where the triangle angle sum theorem says, hey, all three angles together will equal 180. I know if I have a right triangle, that right triangle, that means that that's 90. Its acute angles will always be complementary. It's like, of course, they have to. Because they have to add up to 90. Does that make sense? Okay? So if this triangle has this right angle here at C, then A and B have to be complementary to one another. That the two angles will add up to 90. Now, there's also a second corollary, there's 4.2 that says, once again, if I have a triangle and there's a right or an obtuse angle, there can only be one of them. Now think about what it would mean to have like two right angles. Is that possible? No.
No.
90 plus 90, I would have a third angle of 0. Can't. How about 120, 130? I'm already well above the 180. I can't have more than one right or one obtuse angle and expect it to be a triangle. Like it just makes sense. Okay, so we can use this once again to help us find those angles. If there can only be one right or one obtuse, and if I have a right angle, then the other two are going to be complementary. It's just relationships that make sense if you stop to think about it. So it says find the number of each measured angle. Ooh, where to begin?
Well,
Where do we
it's
begin?
not like as bad because we know that 4 is equal to 90.
How
and
do you
then-
know that?
Well, I mean, it doesn't specifically say it.
I have my doubts. do? I kind of like the idea of finding one first. How could I find one? How can I figure out this one?
The same way we use the other theorem. I forgot what it's called. What's it called?
Exterior
Exterior angle theorem.
exterior angle theorem says the measure of angle 1 is going to equal what? The two angles that are opposite edge, right? Those interior angles, 32 plus 38.
Yeah, one second. So wait, how do we not like know that angle 4 is for sure 90 though?
Well, honestly, when I look at it, I see an obtuse angle.
Same.
The only way that we would know for sure,
Never mind. You're right.
the only way we would know for sure is if they literally had this and they put that right angle symbol in
Okay.
there,
Yeah.
which geometry textbooks tend to do.
I kind of see.
But
that
I
now,
understand. I started looking for right angles too. But was one easy to find using this exterior angle theorem?
Yeah.
Yes. If I know that, can I determine 2?
Yes.
Mhm.
Using what?
The vertical angle.
That's not a vertical angle. We'd have to know this angle then to get the vertical angle, which we could, but that would be 2 steps. We're not going to just relate 1 and 2.
So well, since they're like
Why could I do that?
Because they're, wait,
180 subtract 70. Why do I say it's 180 subtract 70? What are 1 and 2?
32 and 38.
No.
Wait.
Angle 1 is right here. We determined what that was, which was 70 degrees.
they're corresponding, right?
They are not corresponding.
Wait, what's the name for it? It's like when the two angles are like side by side.
And they form a straight line.
Oh my gosh. Wait, yeah.
Perpendicular.
I have a packet somewhere.
Angle 1, angle 2. I guess really this is the other way around. This would be here, angle 2, angle, that's all right. Angle, I'll get it right. If I have this, what do I call these 2 angles? Starts with an L.
Oh, linear.
Linear pair, or I can also say
Linear sides.
linear pair, or they're supplementary. They are a linear pair. They make a straight line. They are supplementary to one another as a result, which means that the sum of them add up to 180. So if I just want to find 2, I just take 180 subtract angle 1. And I'm left with what?
110.
110. Kind of makes sense because that looks like an obtuse angle right there. Okay?
Well, no, it really doesn't though.
It doesn't?
Wait,
2?
yeah,
Yes.
2 looks obtuse.
Maybe you need to shift over, Nathan. It looks very obtuse to me. I admit, if I look at it from this side, it doesn't seem like it. Does that seem larger
wait.
than 90?
Yeah, never mind. It's like, okay,
Do you see what I mean? I understand your point of view. You got to look at it head on. So we know this to be 110 right here. Okay, can we figure out 3? Whew. Do we have any way of figuring that out?
Well, they're 32 and,
Well,
3 are,
do you know what this is?
no.
no,
Why not?
because we're.
No, that's 70.
Thank you, Nathan. Why is it 70?
Oh, yeah, because it's right across. They're vertical.
They're vertical angles. So we know that this one is 70. If we know that this one is 70,
Then that
We
means
can add them together and subtract from 180.
So now we can figure out the measure of angle 3. Measure of angle 3 is 180 subtract 64, subtract 70 because of the triangle angle sum theorem. So the measure of angle 3 is equal to 110 subtract 64. 46. Okay. Can I determine 4? Yes, I can. In this case, I don't just have a linear pair. Okay? I have 3 angles, this one, and this one, that are all making up the straight line.
So 32.
They're still supplementary. My measure of angle 4 is equal to 180, subtract 32, subtract 46, oops, I did that one wrong. There, 180, subtract 32, subtract 46.
Yeah, you would add them.
And I end up with 102, which makes sense. This one is obtuse. Since I know that that's 102, can I find 5?
Yes.
How do you 102?
180, subtract 32, subtract 46.
Oh, okay.
Because all 3 angles, this 32 and angle 3 and angle 4, are all supplementary. They form a straight line. Okay, and now measure of angle 5 is also 180 subtract 102 subtract 41, which is 107, which makes no sense. I did my calculation wrong. You know, I look at that and I go 107, I'm like, wait a second, 107 plus 100, ooh, that's more than 180 already.
Hey, well, okay, wait. Did you, like, do the same thing you did for 4? Because, like, in that case, like, you could just do,
Yeah, there's that.
yeah.
Yeah, no, all I did was put it in my calculator wrong.
Oh.
But you know how sometimes you're like, well, that's what the calculator told me, and you just put it down, and you're like, you don't check to see if it's reasonable. You try to always make sure you check to see if it's reasonable. Does that make sense?
Yeah.
So in this case, to get 1, we use the exterior angle theorem. To find 2, we use the linear pair and supplementary angles. To get 3, okay, at that point we talked about vertical angles and our triangle angle sum theorem. Okay, to find out 3. And then to find 4, we just looked at supplementary angles. And then 5 was once again the triangle angle sum theorem. So you have to use those theorems, you have to use those definitions in order to figure things out, but all it is defining those relationships. Okay, so we had a listing here. If we were to look at 1, 2, 3, 4, 5, let's see if they got the same numbers. 70, 110, 46, 102, and 37 are all the numbers that they got for us. Let's see what they say. Let's see if they made a mistake or we made a mistake.
Look, we both made a mistake.
Hopefully not. That's usually not the case. So they use the exterior angle theorem. Figure out 1 is 70. Check. The two angles form a linear pair, so they're supplementary. As a result, angle 2, 110. Check. We'll pick up again on this tomorrow, and you'll have this homework due really tomorrow night.